Okay, so all of the learning targets are on this slide here because we're kind of starting to put everything together. I know that it's kind of early in this unit still, but we are really starting to put everything together. So we're really going to focus on rewriting exponential equations as logarithmic equations today. We're going to talk about natural and common logs. We're going to talk about evaluating expressions. We won't talk about graphing yet, but we will get into that in the future. The other thing we're hitting today is we're working on solving logarithmic and exponential equations, and this are super related, so they kind of go, you can't really separate them. Our big idea for today is just that we're really trying to find the number that works for x in an equation that looks like this one. And so usually we try to do something to the equation to get x by itself. And so the goal of today is to find the new strategy that does that for us. We could probably think about this one. We could say 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. And if we kept going, we'd eventually get there. 2 to the seventh is 128. So we can see that the 7 is what the x is, but this is not the best method. And I say that it's not the best method because can you imagine what would happen if our exponent was way bigger than 7? We would have to spend a lot of time figuring this out. And what happens if our base isn't a nice number like 2? What if it's like 1.07439, something like that? So we can use logs instead of doing that so that we can get a precise answer a little bit more easily. I know there's kind of a lot of words on this slide, but let's just kind of go through what it says. It says logarithms, this is this new thing that we're learning today. Logarithms are a way of rewriting exponential equations. So this is an example of an exponential equation because it has an exponent in it where the variable is in the exponent. That's an exponential equation. What this is saying, what this equation says, what power of 2 gives you 128? Well, that's exactly what this expression right here says. It says, what power of 2 gives you 128? The answer to this thing right here is the x, and the x was an exponent. So I just wanted to remind myself that the x way up here was an exponent, and so that's why I'm saying the answer to this expression is an exponent. What you should write down or keep in your notes or do something or maybe screenshot is just this line right here. What it says is these two ways of writing the same thing are the same. So if we try to kind of figure out where things go in this equation, now this is kind of like what we saw on the last slide. We had that b, and that b became this little base of the log. The exponent was, I circled it in purple, I remember, so I'm going to do that again, gave me this. And then there was that kind of, which is the output there. Okay, so we can kind of color code this and rewrite either equation one way or the other one. Sometimes it's better to write it like this, and sometimes it's better to write it like this. It depends on the situation. What you really need to know is that they mean the same thing, and that we say log base b of x to say this part out loud. What it means is what power of b gives you x. Okay, so if we just rewrite this equation, this is exactly like what we just saw on the last slide. So our x is our x, just kidding, I'm sorry. Our x is this number right here, and it's gonna go here. Our 3 is this number, and it's gonna go here. And then our 81 is our x number, and then that one is gonna go here. So if we just rewrite the 3 to the x equals 81 equation like this, what we get is log base 3 of 81 equals x. And so this is our new rewriting of this equation. This is not really telling us much yet, but I'm just getting to the point of being able to say this is how we could put this in our calculator. So this could actually give us an answer if we put this in our calculator, and we'll talk about that in the future. By the way, let's just evaluate log base 3 of 81. This is saying what power of 3 gives me 81. Well, let's think about it. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. And then 3 to the 4 is 81. And so we know that log base 3 of 81 is 4 because 3 to the 4 is 81. Here's another one of these, and remember that really what we're doing is we're just rewriting. And so let's just pay attention to where things go in the equations. So just color coding again, really what I'm trying to say with this slide is that the reason that log base 4 is log base 4 of 16, the reason that log base 4 of 16 is 2 is because 4 squared is 16. So there might be times where I ask you, can you evaluate what is log base 2 of 8? And you might have to say, well, log base 2 of 8 is 3 because 2 to the third is 8. So this one's a little bit of a challenge because 8, let's think about this for a second. 8 to the 1 is 8. 8 squared is already 64. So we know that it's somewhere between 1 and 2. We know that the answer is somewhere between 1 and 2. But we don't know how to get the answer yet. So here's what I'm going to do instead. I'm going to write log base 8 of 32. So here's what I noticed. Log base 8, well, 8 is 2 cubed. And then 32 is 2 to the 5th. And so I'm going to write 2 to the 5th here. Equals some number. So we have to figure out what is the value of this. I'm going to put an x here. Okay, so this is saying 2 to the third to the x is equal to 2 to the 5th. And so now I should be able to use exponent properties to solve this equation, because what I see here is I see 2 to the 3 to the x is the same as 2 to the 3x equals 2 to the 5. And so now I should be able to say, well, if I know 2 to the 3x equals 2 to the 5, then I better be able to say that 3x equals 5. Because I noticed that these exponents had better match because the bases already match. So then, if I know 3x equals 5, then I can divide by 3. And I get x equals 5 over 3. So I know that log base 8 of 32 equals 5/3 because 8 to the 5/3, 5/3 equals 32. Last time I used this, we were in breakout rooms, so ignore that instruction, but let's evaluate some of these. Log base 2 of 8 is what? Because 2 to the what is 8? 2 to the third power is 8, and so log base 2 of 8 must be 3. 5 squared is 25, so log base 5 of 25 is 2. 3 to the negative 2 is 1/9, because remember this is 1 over 3 squared, and that's equal to 3 to the negative 2. We have that exponent property that says that. So log base 3 of 1/9 must be -2. I know that the square root of 16 equals 4, and I know that the square root of 16 is the same as 16 to the 1/2. So my answer here must be 1/2. I know that anything to the 0 power is 1, and so 9 to the 0 is 1, and so the log base 9 of 1 is 0. This one is interesting because I know that there's no way that I can get negative numbers out of this, and so this is actually undefined because there is nothing I can put in here to make this equation true. Let's just do a little rewriting here. Basically, we just need to write, okay, well, 2 to the 8 is 256, therefore log base 2 of 256 equals 8. I want you to try this one, and then I'll go through it. Here goes. Log base 27 of 9 equals 2/3. And last but not least, log base 10 of 0.001 equals -3. There are two important logs that you need to know about. The first one is log base 10, and log base 10 we just write as log. So there's a button on your calculator that looks like this and it says log in it. That's what this button is. It's log base 10. I need you to know that that's called the common log and that it's base 10. The other one is the natural log, and so we've seen some equations that have e's in them, and we write ln for that. It's just the way that they say natural log in French, and it's log base e. In your calculator, there's going to be a button that says ln, and that is that button.